Okay, so here we go. This is going to be kind of weird, but I know you guys can't see this. I just realized my videos are kind of out of focus, so look up close. We're going to have to zoom in and out to do these problems. So, we're going to graph this, and this is the graph of a hyperbola. So in this case, what we're going to do is start off by graphing the center, and we're going to find our center is at the same place we had last time. Just change the sign. So I'm going to change the 4 to a -4 and change the 2 to a +2. And then I'm going to find my A value the same way we did last time. Okay, what's my A? In this case I have 1, so I know my A is 1. And B is the square root, the square root of 1, right? That's 1, right? The square root of 4. What's the square root of 4? 2, right? So in this case, we're going to use B and A in a different way, okay? What I want you to do is notice that this right here, what is that? Is that a plus? All right, ellipses have a plus, okay? But these graphs right here are called hyperbolas, and they look a lot different. Okay, so here we go. We're going to start to graph it. So let's put our center down. So our center was on -4, +2. And then we see that the number with the x was an invisible 1, so we're going to go to the left and right 1, okay? And then we go up and down the square root of 4, so that's 2. So I go up 2, and I go down 2, okay? Now, notice we're not doing an ellipse. There's a minus there, so that means we have to do something different. This is a hyperbola, so in this case, draw your box right there, and that is the beginning of our hyperbola graph, all right? It gets a little harder. The next thing you have to do is draw your asymptotes. And these are going to be lines that help us figure out the boundaries of our hyperbola. So a hyperbola is a special kind of curve that there's two ways to have it, okay? Either we have y minus 2 squared equals 1 over b. So what did I copy the 2? That should have been k over a squared. So this still has a center at h and k the same way, okay? This is a hyperbola. Okay, this is the graph of a hyperbola. And if the x is in front, and this we have x minus y, that means this hyperbola is going to be opening left to right, okay? If we had the other case around, if I had y minus k squared minus x minus h squared, okay, over b squared, and this is my a squared, okay? This would be the graph of a hyperbola that opened up and down, okay? This would be the graph of a hyperbola that opens up left and right, okay? And the left and right pieces right here, these points I mean, are the vertices, okay? And we call these points the vertex, okay? This is the vertex of this branch of a hyperbola, okay? And this point is the vertex of the other branch of a hyperbola. So now you have to know that since our equation has an x in front, which one are we doing? Are we doing the up and down one or the left and right? It's going left and right, isn't it? So that means our center vertex is going to be this point. So that first thing that we do with our cross, it's convenient that we know that point's on our hyperbola. Okay, so we know it's going to open up to the left and right. Now, the way I've trained my students to do it is to calculate at least one point that's on the hyperbola. And I'm going to spare you the long lecture that we got this from. But you're going to go ahead and choose y to be k plus b. And in that case, x has to be equal to plus or minus a root 2 plus h. So in this case, our k is +2, right? You change the sign. And b is the square root of 4, that's 2. So we got 2 plus 2. So we see y equals 4. Basically, we're trying to pick a number that goes in here, right? What's 4 minus 2? 4 minus 2 is 2, and 2 squared equals 4. So you want to have a number on top that equals this number. And we're basically trying to make this whole number in the square equal 1 if you want to use this formula, okay? So if y equals 4, then we plug in some numbers into here to find the rest of our equation, okay? What's a? A is the number underneath x, and here we have a 1, so it's an invisible one. We're not going to write it. And the square root of 2, we're going to substitute for about 1.4 for the purposes of our graph, okay? And h in this case is minus 4, because don't forget to get h and k, we have to change the sign. So in this case, h is minus 4, right? See, this is minus h, and this is plus 4, so you're supposed to change the sign to get h. So, what's 1.4 minus 4? Right, we're going to get negative 2.6. And if we have negative 1.4 minus 4, we're going to have negative 5.4. Okay? So here we go. This is the way it works. If y is equal to 4, then we know x has to be 2.6 or negative 5.4. Negative 2.6, right? So let's go to x equals negative 2.6. That's right about here. All right? And we're going to go up to y equals 4. Okay? And then we're going to notice the symmetry. We're going to look at this line of symmetry we have right here. And we see that this is 2 steps up, so we're going to go 2 steps down. So this point also happens to be on our hyperbola. All right? Now we're going to go over to the next value for x. X equals negative 5.4. And that's about here. Right? And so here we go. So we've got negative 2.6. So, next thing we do is go from 5.4 to 4. We just go up. Okay, I think I made a little arithmetic mistake, sorry. And so we go up 2, and then we go 2 there. So at any rate, this side is good, I know that much. So we're going to go like that, okay? And so that's one branch of our equation. We just made it go through this point that we found and this new point that we found, that if y is equal to 4, then x had to be these values over here, right? Yeah. Oh yeah, my fault. That's what I did. I meant to put this point on the negative side. Sorry. So yeah, it is negative 2.6, but negative 2.6 lies around here on the other side of negative 2, right? So sorry about that. This goes here, and that goes there, and then we draw our hyperbola, okay? So you got to know that it's a curve. It looks something like that. If you look at what this thing does, it might even confuse you a little bit. So I'm going to zoom in so you guys can see that, okay? Zoom back a little bit. It does exactly what we were talking about. At about 2.6, it's at 4, and it's also right here on the graph. And if I go to about 5.4, right here, right before negative 6, I'm right there on the graph, and I'm also up here at y equals 4, right? So that's the way this trick works. Let's try another one, and then I'm going to have to call this video off because I know this is kind of a tough problem for you guys to get anyway. I'm not sure how many of you are really going to study this before the test tomorrow, but hey, if you're just studying for the fun of studying, then keep watching. So let's put the center of our graph. I want to zoom in actually so you guys can see this equation, okay? So in this case we have x plus 2 minus y squared, okay? So we're going to find that center point, right? Don't forget to change the sign of this number. We get negative 2. And like I said, when there's no number in here, we got a 0, okay? So notice this isn't a plus, it's a minus. So that means we're doing a hyperbola again. And the center of our box is going to be at negative 2, 0. We're going to get A and B in the same step also. So in this case, A is 1 and B is 1 in this case, right? Because the square root of 1 is 1 and the square root of 1 is 1. So there we go. We know we're going to go up 1 and down 1 and left and right 1 from negative 2, 0. So I'm going to go to negative 2 and 0, and I'm going to go up 1, down 1, left 1, right 1. And I'm going to make a box like this right here. And then I'm going to draw my asymptotes by connecting the corners of that box. Alright, there we go. Dot, 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 dot. So here we go. So is this going left and right or up and down? Since x comes first, that means we're going left and right. So put that point and that point. And like I said, we wanted to pick a number for y that makes sure that this whole thing is equal to 1. So I want this to be 1 over 1. So I would have to plug in y equals 1 for that to be the case. And if you pick the 1, if you pick y that makes this 1, that means that x equals root 2 times a plus h, and the plus or minus. So in this case, a is, again, a was 1. So we have plus or minus root 2, which we're going to write as 1.4, plus h, and in this case, h is going to be minus 2. Don't forget to change the sign of h, okay? So we got the plus 2, and then h means you change the sign to negative 2. So now we got 1.4 minus 2, we're going to get 0.6, and then negative 1.4 minus 2 is negative 3.4, okay? So I see if y equals 1, then x has to be 0.6 or 3.4 negative. So let's go to x equals 0.6 and go up to 1. And then since I see from here I went up 1, I'm going to go down 1 also because it's symmetric. And then we go over here, x equals negative 3.4. That's a little bit before we get to 4, and there we go. Better fix this asymptote, because the asymptote is supposed to be an imaginary line that it never crosses. So it better not look like it crosses it. That's exactly what it doesn't do. So here we go. We got, well, let's just look at the official graph, okay? I'll put my structure on top of it. So you see we put the center right here. We went up, left, and right. These are our asymptotes, okay? And our graph went through the points that we said. At 0.6, we were at 1. At 0.6, we're at 1. We went up and down the same distance. Then at 3.4 negative, we went down to 1. Okay, so this is how you do these problems. I know they're kind of tough. They're a little harder than your typical graph. So let's try one more to see if you guys get this, okay? Go ahead. Look at this equation, write it down, get a little piece of graph paper and try to get this thing going. So I'm going to zoom back now, and I'm going to let you guys try to do this problem on your own, okay? And ready, go. Press pause and try it on your own. So now, let's see if you got the right answer, okay? If you can't see, this is at negative 2 and negative 2, okay? And since we had y came in front, that means our thing was opening up and down. Our hyperbola was opening up and down. And since 4, the square root of 4 is 2, we went up and down 2, okay? And since x, the number underneath x tells us how much to go left and right. So I go to the left 3 and to the right 3. And then we had our box and your asymptotes, okay? Should be opening up and down. So I gave you a vertical one, even though I haven't given you the formula for that one. Probably shouldn't have done that. Let's try another one. Going with the number under both of these things. There we go. Another up and down one. Here we go. We can work with this. Okay, this is closer to the kind of problem I'm actually going to give you on your test. So, take a look. And let's graph it. Alright, you see it? Write that down, pause it if you have to. And then let's see if you can graph this, okay, on the paper. Try to zoom as close as I can. See if that's too much. And let's check. There you go. So I hope you got the idea. This center, x is at 0, y is at -1, so that's why we went down to that point. Then the number underneath x is 25, so I go to the right 5 and to the left 5, right? And then this is 16, take the square root of that, and I go up 4 and down 4. Since you see x is in front, you should know this parabola is going to open up left and right. And it has to start right here. Then we would do, we would pick y to be 3, because we want to get 3 plus 1 equals 4, so that 4 squared gives me 16 over 16, and I would have x equals plus or minus a, root 2 plus h. And in this case, our a is 0, because, oh no, it's 5, sorry. So we got plus or minus 5 root 2, and our h is 0 in this case, right? So we have plus or minus 5 times 1.4, and that gives me plus or minus 7, right? So if x is equal to 7, that means I have to go to y equals 3. So let's look at x equals 7. Oh, look, I'm at y equals 3. All right? And then since I went up 4 steps, I'm going to go down 4 steps. And hey, look, that's right on the graph. All right? And it's the same thing for -7. That means I go up to 3. All right? Since, look, I went up 4 steps, I go down 4 steps, and I would draw my hyperbola through here. All right? So good luck doing these problems. Good luck on the test tomorrow. I feel like throwing one more at you for some reason, okay? So let's see what happens. But if I upload these any later, you're not going to get to see them anyway. So go ahead, try to do this problem, pause it, and good luck. And here we go. See if you got it right. All right, our center is right here at -3 and 0, because there's nothing with y. Underneath x, we have a 1, so we go left and right 1. And then this is 25, so the square root of 25 is 5. So we went up 5 and down 5. The x is in front, so it goes left and right, and I'll spare you the lecture on how to calculate the points, okay? Good luck on the test tomorrow, guys.